Right guys, relative motion. Now I want you to bear with me a little bit with this because this can get a little bit confusing because we always need a reference point. So when we're talking about relative motion, we're talking about bones moving in relation to each other. So when my inanimate bones move, they move in relation to my sacrum. When my sacrum moves, it moves in relation to my inanimate bones, etc., etc., etc. So we need to know that reference point. So movements at the pelvis, it's the same as inhalation and exhalation. We have external rotation, and with that comes sacral counternutation. So these inanimate bones externally rotate and allow this sacrum to counternutate and tip backwards. When these inanimate bones internally rotate, this sacrum will tip forward. Now, the way I visualize this is along with the other joint actions that go with ER and IR. If I'm standing upright, and my pelvis goes into external rotation. And remember, external rotation comes with flexion and abduction. That means that's going to come forwards and out. So pelvis goes into external rotation. In order to stay standing upright, my spine coming down here, my sacrum needs to tip back. If not, it tips forward. If not, I'm no longer standing upright. I'm now pointing forward. I go into an orientation. Yeah? So if this sacrum doesn't tip back, my spine points this direction. Same thing with internal rotation. Remember, internal rotation is paired with extension and adduction, so adding things close to the body. So if I go into extension and adduction and internal rotation, my sacrum needs to nutate. It needs to come forward. If it doesn't, then my spine goes that direction. So in order to stay standing up, I have to have these joint actions or these relative motions happen at my sacrum. Otherwise, I'd just be like boom, 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 all over the place. That's how I visualize it. In order to have this motion where my inanimate bones tip backwards, I need to have my sacrum come forward. Does that make sense? I hope it makes sense. Cool. So what happens at the femur when we externally rotate? When I go into external rotation here, I'm also going to go into external rotation at the femur. And you see how that that femoral head slips forward in the socket again. So when I go into ER, this goes into ER and slides forward. Same thing as when we went to a posterior orientation. External rotation, femoral head slides forward. External rotation. Down at the tibia, we also have external rotation. But, remember the whole windmill thing? Things move faster the further away they get. At the tibia, I have more external rotation than I have at the femur. So my femur goes into external rotation, my tibia goes into more external rotation, which means in relation to my tibia, my femur is relatively internally rotated. Even though we're in external rotation, it's relatively internally rotated compared to my tibia. And I'll demonstrate this with my elbow. If I flex my elbow, that is elbow flexion. Yep, everybody can agree. That is also elbow flexion, but it is relatively more extended than this. It's less elbow flexion. That is elbow flexion, but it's not as much elbow flexion as this. So I could say that this position here is relatively more extended than this. If we compared the two, you would say this is relative elbow extension in comparison to this motion. Should do that with my t-shirt off really and fucking pump the guns up. So we can get this confusing language where we're like, pelvic external rotation, femoral external rotation, tibial external rotation, but relative femoral internal rotation. See? And at the foot supinates. So we get this high arch on the foot. So just to recap, external rotation, external rotation, external rotation, supination. And then internal rotation, the exact same thing happens, but the inverse. So internal rotation, femoral internal rotation, remember this head slides backwards, tibial internal rotation, foot pronates, flattens out, pushes into the floor. But the tibia is going to move faster than the femur, so the femur could be said to be in relative external rotation compared to the tibia. So this moves more, this moves less, relatively more externally rotated in comparison to the tibia. So that's where the language gets a little bit slippy and a little bit kind of like, oh, but I thought when we went into external rotation, the femur did externally rotate. It does, but it can be said to be in relative internal rotation compared to the tibia. So we always have to have that reference point, and I will try to always give you a reference point. Sometimes it slips up just because language, but I will always try to give you that reference point so that you understand that we're talking in relation to another bone. So it could be said that the femur, so the pelvis is relatively internally rotated in comparison to the femur, because the femur externally rotates more. Anyway, right, chew on that.